particular satellite dish is in the shape of a parabolic surface. That is, its cross-section is a parabola. Signals coming from a satellite dish strike the surface of the dish and are reflected to the focus, where the receiver is placed. This satellite dish has a diameter of 12 feet and a depth of 2 feet. How far from the base of the dish is the receiver? So a parabola has this nice reflective property that anything that is traveling parallel to the axis of symmetry, when it strikes the satellite dish, would reflect to the focus. And this works for radio signals and microwaves and light and everything else. And so this is how satellite dishes work. Even radio telescopes work this way. So if you have a satellite TV system, you have a very tiny satellite dish that works this way, and apparently this is a very big satellite dish. Now, I was a kid in the 1980s, and this was the kind of satellite dish like people had in their backyard. And so I'm picturing one of those giant satellite dishes. And so instead of trying to draw a 3D picture here, I'm just going to imagine that cross-section, that slice kind of down the middle, right? That the satellite dish kind of looks like a parabola, and that across here, right, is 12 feet across, and then it's 2 feet deep. And I'm supposed to figure out where the receiver would be placed, right, away from the base, this distance. Well, if I think about it, right, that's the vertex. The receiver is supposed to go at the focus. And so this distance we're being asked to find is the value of p. So if I can find an equation for this parabola, I should be able to figure out what p is, and that'll answer my question. Well, the way I've drawn this picture, this is an x squared equals 4py, and in fact, p is going to be positive because I drew my satellite dish facing upward, which is fine, though very technically for this problem, it really wouldn't matter because we just need a diagram. But also in choosing this, I'm telling you that I'm putting the vertex at the origin. And I think it's a good question. Why did you decide to do that? Well, the answer is because it makes the equation as easy as it can possibly be. And since there wasn't already a coordinate system in place, I get to decide where the where the vertex goes, where the origin is. All right, well, when I look at this equation, I see 1, 2, 3 unknowns. So if I had a value for x and for y, I should be able to find p. That's where I'm going to use this 12 and this 2. The satellite dish is 12 feet all the way across, so if I just went over from the vertex, that's 6 feet. And then I go up 2 feet. That tells me that this ordered pair is 6, 2. Well, I can plug x in for x, y in for y. That point has to be on my satellite dish. It has to be on this parabola. 6 squared is 36 is equal to 4p times the value of y, which is 2. So 36 is equal to 8p. P is equal to 36 over 8. I can reduce that to a 9 over 2, and that's a distance in feet. The receiver. Should be 9 over 2 feet, which I think I'll say 4.5 feet from the base. All right, if you have a satellite dish at home, be very careful. Measure across it. Measure up to the focus and measure how deep it is, and you can check to see if that receiver is in the correct place. That's it for now.